1 second. There, can you hear me? Well, it's always a pleasure to follow Stuart because he gets you to think from the perspective of a microbial ecologist, and that's what I am. I study the ecology of bacteria in particular and the evolutionary history of the resistance genes they carry. Now, I'm a little out of place here because in my lab we're focused on the microbes, and here all I see is a bunch of humans. So I was told I can't use PowerPoints, but nobody told me I couldn't bring props. So I brought my microbiome, and here it is, and with my Kleenex. And I'll bring a few of them up above so you can see them. But what's wonderful about my microbiome is it's beautiful, it's colored, diverse, and it's mine. It's not yours, Stuart. You have your own. So this is my microbiome. And each of you has a microbiome, right? And that's the reason, or part of the reason, you're healthy, that you grow to your full potential, that you can consume the foods you want and get nutrition out of them. It's these guys doing their job. So what I'd like to do is tell you a story. I went to a doc once, I think it was this guy, E. coli, right? A lot of women in the audience have had a urinary tract infection, I'm sure, right? Often, 80% of the time in community-acquired UTIs, the culprit is this guy, E. coli. And so I went to the doc and said, here are the symptoms, what are we gonna do? And my doc, very progressive, said, okay, I'm not gonna bother culturing it, it's probably E. coli, take this antibiotic, go home, and do the full course peg, because we don't want resistance growing, you know? So yeah, I got it, remember? I studied that. So what do I do is I go home and I take this antibiotic, and I'm sorry guys, but it's like the equivalent of an H-bomb. All of my microbes get decimated. Now why do I say that? 9 out of every 10 cells in my body is a microbe. I'm gonna say that again because some people are surprised still. 9 out of every 10 cells in this body are these guys that are making me healthy. And when we use conventional antibiotics, we're essentially using what is analogous to a hydrogen bomb. We are just decimating that majority of our body's cells, which are microbial. Now, certainly some will survive, and in my case, this guy survived, my E. coli, because it was resistant. And when we don't culture the bugs and test them for sensitivity to antibiotics, we will often misuse drugs and give me the wrong drug. Okay, so I'm an experimentalist, so I gathered up my microbiome. My friend said, Peg, eat yogurt, take probiotics, your microbiome will come back. And here we go, I've got it back now. Where'd my, oh, there's my E. coli. So I got my microbiome back. But this time I did what I should have done the first time. As a microbial ecologist, I should have said, hey guys, I got a problem and I'd like you to solve it for me. Would you? And as quick as that, problem was gone. What did they do? There was no H-bomb involved. It was one other bacterium who happened to be a very close relative to that nasty one that I just threw away because it's now dead. This guy produced a protein that targeted specifically my urinary tract infection strain. Nobody else. In fact, the rest of the microbiome was having a party and didn't realize that this little battle was being waged. They had no idea because this guy did its job right. Now that makes sense. Why? Because bacteria don't live in isolation. They can't live in isolation. They need this consort, this diverse community to make a living. So let's compare and contrast the two views. We have utilized the fact that a very few lineages of bacteria produce conventional antibiotics, and I mean broad spectrum, penicillins, ampicillins, tigecyclines, all of those. When we use them, it's the equivalent of an H-bomb, and the outcomes are pretty bad. First, they often don't work anymore, right? That's why we're all here. Second, they actually cause problems to us. Our body system responds in negative ways. We get things like oral thrush or diarrhea. We feel pretty crappy. Third, they select for intensely high levels of resistance. Because if my microbiome, and I'm just going to guess, is 10 to the 18th cells, and the mutation rate to resistance is 10 to the minus 6, you guys do the math, I've already got thousands of resistant strains in my body just through spontaneous mutations. This is not a good thing. Now let's look what the microbes have done over 2.5 billion years. They've invented a different approach. It's called the guided missile. You guys remember CNN, the Gulf War, and all of a sudden we had this views of the guided missile going right down into a building in the middle of, downtown Baghdad, right? Well, the guided missile is the way microbes have evolved to deal with the interactions that go astray in their communities. They don't decimate their community. That's just a foolish thing for them to do. So they've evolved this sophisticated defense system that includes things like bacteriocins, which I would imagine none of you have ever heard of, but you will in the next 15 years. Phage, many of you have heard of phage. Those things are pretty powerful as a defense system. E. coli can kill other E. coli with a phage. E. coli can kill other E. coli with bacteriocin. So I just want us to think for a minute about, there are two approaches. One, if we keep using it, which is what pharmaceutical industries have been prodded to do, we keep asking them, develop more antibiotics, we need them, we're desperate, we're dying. And their business model is based on a single pill that does the job, right? Well, I think it was Albert Einstein who said, if you do the same thing over and over again and expect a different result, that is the definition of insanity. We're asking the pharma companies to essentially be insane because we know the outcome. Another tigecycline, another chloramphenicol, another penicillin will simply select for massive resistance as soon as it's on the market. And that's exactly what's happened with the very few novel antibiotics we've produced in the last few years. So we need to refocus our energies on this problem in several ways, and you can help. One is, we have to regard this microbiome that I threw on the floor, unfortunately. I thought I might have a table to put them on gently. I threw them on the floor, but they are precious to us. And they deserve, we owe them our respect, and they deserve our respect because they are what makes us feel good, feel healthy, function properly. Second, they are far wiser than we are. They have seen it all in 2.5 billion years. And if you think you're going to invent a new drug that they can't resist, well, I'm really sorry. That's just silly. They've already got it. As Stu is talking about, there are genes out there that have nothing to do with antibiotics that they will co-opt in a half a second. If they're going to try to survive in the face of that drug, they'll find a way to do it. So, and then finally, why not learn from these guys? We have a plethora of new drugs to look at, to explore, to begin to imagine whether they might serve as the new paradigm in attacking infectious disease. And I use that word in humor because we shouldn't be attacking anything. These are misunderstandings that are happening in our bodies. And we've got to figure out ways to get rid of the misunderstandings. And so one approach I've done in the last 15 years is, since I couldn't get pharma industry involved, I started a small company on my own, and we're about to release a drug to the veterinary community that will deal with mastitis. And how will they do it? Exactly the same molecule that I used to kill that UTI strain. No collateral damage, no strong selection for resistance, and best of all, it works. And it's not toxic. You guys have probably eaten that drug on foods in McDonald's, if you've ever gone to the salad bar. If we'll probably have cheese back here and some preserved meats. It's in there. Your body doesn't recognize it as a problem. So that's just one possibility amongst the many that exist that the basic biologists are exploring, the basic microbiologists are exploring. And our job now should be to say, guys, we need something new. Let's go for it. Let's try something different. And above all, let's love our microbiomes. Thank you.